YouTube. So today we're going to continue our BGP routing, and the last time we did iBGP, okay, external gateway routing protocol between router 1 and router 2, because they are different autonomous systems. Router 1 is in autonomous system 1, router 2 is on autonomous system 2. So today is going to be iBGP, okay, between router 2 and router 3, okay. So to enable iBGP, first we have to make sure that there's OSPF running between these two routers. Okay. Once OSPF is running, now we're going to make sure there's connectivity, okay, between the loopback interface of router 2 and router 3. And once we establish that, then we're going to just do the BGP peering, the iBGP peering, configure that. And then once that's done, then we make sure that there's iBGP also running between router 1 and router 3. Okay. So let's bring up, let's check router 1. On router 1, if I do show BGP IPv4, that's the summary. Okay, we see it has only, router 1 has just one neighbor, okay, and that's router 2. It has only BGP peering only with router 2, and if I do show IP route BGP, okay, so this is the only prefix is getting, okay, and that's a prefix for the loopback of router 2. And in the same way, if I go to router 2, I do show IP BGP summary. This is actually the old command. It's the same thing like show BGP IPv4 summary. It's the same command. Okay, so for this one we can see that the R2 has peering with router 1. Okay, this is the router 1 neighbor, and it's router 1 is sending to R2 5 prefixes. Okay, so for that, we can check if I do show IP route BGP, you can see all the 5 prefixes. So I've been sent 1, 2, 3, 4, 5. Okay, 5. This one is summarized. So anyway, so we have so this in router 3. If we check router 3, there's nothing running on router 3 at the moment. So router 3, if I do show IP route BGP, okay, there's nothing. Show run router, okay, there's nothing. So the only thing I configured on router 3 is the interfaces, okay, just so that we have initial configuration. Show IP interface brief. Signed. So these are the interfaces I configured on. So pay attention, it's just this interface. This is the one that's linking router 3 and router 2. Okay, so we're going to enable OSPF and inject this interface and also the loopback interface into OSPF. So right now we're going to start with the OSPF configuration. We're just going to make sure that wait a minute, maybe it's just ping. Let me see if I can ping the other interface on router 2. Let me lower this out. If I bring router 2, put it here, I do show IP interface brief, router 2. So what I'm trying to do is I want to ping this interface that's linking router 2 and router 1. Okay, so if I ping it from router 3, okay, so that we have reachability, so we can now configure our OSPF. By the way, let's start with start anywhere, but it's going to be configure terminal router OSPF process 1. Let's put the router ID. Router ID, let's put it two. Okay. And then let's inject the network. The network facing the router 3. It's going to be 192.168.2.3.0.0.0.0.5. And that's in area 0. Okay. So for this one, I configured OSPF on the interface itself. Okay, so if I check, if I interface to show interface loopback 0. Okay, so the interface IP is already configured. I also injected OSPF directly on the interface. Okay. Yeah, I think I'm missing one command here. Okay, I'm gonna go interface loopback 0. Okay, I'm missing one command, which is IP OSPF 1 area 0. Okay, so I configured the interface as point to point, but I actually didn't inject the loopback into interface loopback into OSPF. So right now, I'm going to save this, and let me just double check the configuration. Show run interface loopback 0. Okay, we have everything there. Show run session OSPF. Be sure that the router configuration is done. Okay, all right. We put the connecting interface, the directly connected interface we put into OSPF. Okay, so now let's do the same thing on router 3. We're going to do the exact same thing on router 3. So on router 3, I configured OSPF. So I'm going to show run interface loopback 0. Okay. So I put this interface, the loopback 0, I put it into OSPF, made that interface also point to point. Okay. Now also I make sure that the global OSPF configuration is also done. So run the OSPF. Okay. So this is our OSPF running here. And we have router ID and the network also connecting router 3 and router 2. That one is there. So what we have to do right now is just to test OSPF if it's working. Do for IP protocols. Okay. I'm going to see, by the way, just write protocol summary. Okay, we see one of the protocols running is OSPF. Okay, we don't have BGP yet. Okay. So now let's check if OSPF has connectivity. Okay, we do show IP route OSPF. Okay, we see OSPF. We can see the loopback interface. Okay, of OSPF. We can actually see that it's coming from router 2. Okay, so let's try to see if we can ping it. Ping it's going to be 2.2.2.2. Okay. We have reachability the same way we can do. We can ping 3.3.3.3 on router 3. We don't have to do that since there's already reachability on one side. So what we're going to do right now, we're going to start the configuration for iBGP. iBGP configuration is very similar to iBGP. Okay, we're going to see the difference. Let me start the configuration from router 2. Let's say configure terminal. Let's say and we remember this is router 2 and router 3, they are all in the same AS, okay, AS2. So I'm going to go into here, say router BGP2, okay. And then I'll say enable. Who's going to be the neighbor? We're going to define the neighbor by its loopback, okay. So we're going to, unlike the iBGP configuration, For iBGP, we typically would use the loopback interfaces for peering, for BGP peering. So I'm going to use a BGP loopback for router 3, which is neighbor is 3.3.3.3. Okay, the remote AS is 2. Okay, it's the same remote AS, the same AS. So what else? We're going to say neighbor 3.3.3. The update source loopback 0. Okay, loopback 0. Okay, all right. So just like that, is the configuration is done on router 3, on router 2. I'm going to do exact same configuration on router 2, but it's going to be opposite. Okay, so on router 2, router 3, okay, so I define the BGP, router BGP2, which is the same AS system like router 3. And I also define the neighbor relationship, okay, with the loopback of router 2, which is neighbor 2.2.2, remote AS is 2. And also I enable the, I make sure the updates are being updated from the loopback, okay. And just with that, we had a neighbor relationship that came up. BGP neighbor relationship was established between router 3 and router 2. Okay, let's go out of there. Save. So how do we know we have BGP actually enabled here? If I do show IP route BGP, okay, we don't see any routes because no route has been actually injected. No BGP routes have been actually injected, advertised to router 3. Okay, so but I could check if there's BGP peering. Okay, show IP BGP summary. Okay, so we have BGP peering between router 3 and router 2. Okay, how do we know that? We know this is the router 3 here. This is router 2. Okay, and the state has been up since 1 minute, more than 1 minute. Okay, and router 2 is sending 6 prefixes to the router 3. Okay, so how do we see those? How can we see those prefixes? We can do show IP show IP neighbors, show IP BGP neighbor 2.2.2.2. Okay, if I do a question mark, I have to check the routes that are learned from the neighbor. Okay, so if I do routes, okay, so these are the routes that are actually learned from the neighbor. Okay, and we learn these routes, and if you look carefully, you see all this. This one is coming from router 1. This one, all these other ones are coming from router 1. Okay, this is actually a route that is not best. It learned on BGP, but it's not. It's indicated as not the best to be injected onto BGP because it has a beta metric on the with OSPF. That's why you see the R beta sign I there. So and then one thing you have to notice is that the next hop here is pointing to router 1. And router 1, we don't have any BGP peering with router 3. Okay, if you go into router 2, because that's why we cannot have BGP routes yet on router 3 because it's pointing to a next hop. Okay, it's pointing to a next hop that we don't have BGP peering with. Okay, so if I go into our 2, I do show IP BGP enable. Let me say just to show IP route BGP. Okay, So now in router 2, you see, router 2 is telling me, it's giving me the same prefixes with the next hop. Okay, this next hop, we have BGP pairing with router 2. Okay, the next hop that we see here, which is router 1, we don't have that BGP pairing with router 3. Okay, so in order to fix this and make sure that R3 is able to receive those routes that are coming through router 2, we're going to have to go into BGP configuration router 2, your terminal. Okay, so say show router BGP. Okay, so we're going to fix something here. We're going to go configure terminal. I'll say router BGP 2. And we're going to say neighbor. Okay, neighbor is 3.3.3.3. Okay, the question mark. And I'm going to define next hop self. Okay, once I do that, we should be able to have BGP routes being sent onto router 3. Okay, so let's go back. Let's do the same command again. We're going to do right now. We'll actually do the same command. Okay, so now we see a difference. We see a difference because BGP is not synchronized. We're going to see those routes as best routes very soon. Okay, let's see. So we do show IP BGP, so IP route BGP. Okay, so now we are on router 3. We can now see that those routes are coming in to router 2 as BGP routes. Okay, and one thing to note here is the next hop. So here's the next hop now. Originally, when we had next hop as this guy, we didn't have those BGP routes in. Okay, because by default BGP doesn't change its next hop, so you have to manually define it depending on the situations, like this one, whereby to avoid BGP loops, that's why actually we have iBGP. So you have to define on router 2 next hop self. In that way, you're telling router 1, you're telling router 2. Sorry, router 2 is telling router 3 that the next hop to get to these routes is me. Okay, that's how we define it. So now, what we're going to do right now, we have to enable BGP, iBGP between router 3 and router 1. Okay, that's what we have to do right now. All right, so now let's do the iBGP configuration between R1 and R2. Okay, R1 and R2. So basically, we're going to first of all enable these interfaces, make sure the interface is up and reachable between the two routers. And on R1, I do show IP interface brief excluding unassigned. I see that on gig 02, we already have this interface configured. I do the same command on R3. I see that interface also configured, gig 02. Okay, so what if I do a ping? I'm going to ping router 1 from router 3. Okay, that ping is working. So which means we could actually go ahead to do our configuration. So what I'm going to do right now, I'm going to start with our router 1. Okay, I'm going to configure iBGP starting from router 1. So just say configure terminal router BGP 1. I'll say neighbor 192.168.113.3. Okay, remote AS is remote AS is 2. Okay, and Okay, I thought I was missing something. So yeah, so that's how you enable eBGP between R1 and R2, but on R3 is not yet configured. I'm just going to do on here, and if I do show IP BGP summary, you see there's one neighbor whose BGP status is still in idle state, and this is a neighbor. So now we're going to configure that neighbor, okay? And there's something I showed you the last time. If I do show TCP, let's show TCP brief all. Okay, we can actually see right now that we've configured BGP on one side, that router 3 is listening. Okay, so anyways, it's the same command like we did before, like it's the same verification like we did here. Okay, just to be able to see that router 3 is still waiting for the configuration to be done. So right now I'm going to go to router 3. Okay, I'm going to say configure terminal router BGP. The BGP2, enable is going to be 192.168.13.1 remote AS1. Okay, so that the configuration is done. Now there's something about BGP. If you remember what we did here, we saw some routes are coming from router 1, okay, land on router 2, and we those routes were advertised to router 2 and land on router 3, and we had to enable next hop serve here so that those there could be BGP peering between router 3 and router 1. Okay, so we're going to have to do the exact same thing here on router 3. What that means is that basically, since there's iBGP running here, we don't want a BGP loop situation whereby the routes learned on router 3 from router 1 appear on router 2 as if the next hop is, next hop is router 1. Okay, so we have to say next hop serve on router 3. Okay, exact same way we did on router 2. Okay, so we'll go to router 1. Let's check router 1. Let's check show IP BGP summary. We should see BGP came up already or router 3. If I do show IP BGP, show IP route BGP. Let's see what's okay. We didn't see anything special. We didn't see anything. All the routes are still going. We still have BGP. We still have BGP route and prefixes being learned from router 2, which is okay. Now let's do the same thing on router 3. If I do show IP route BGP, okay, nothing special here. The only command we need to add here to avoid BGP loops, okay. Of course, we're going to see we're going to see why we have to enable this interface, okay, because at the end we're going to use it for BGP, manipulation, BGP best path manipulation. So that's why we have to enable this interface now. We didn't have to do it right now, but for now it looks like it's useless. But when the time comes, you're going to use it for BGP route manipulation. So I'm going to do show from router BGP. Okay, so I'm going to add here next hop serve. Okay, configure terminal router BGP 2. I'm going to say enable 2.2.2.2. Okay, this neighbor here. Say next hop serve. Okay, That way, we avoiding BGP loops, okay? So this command is not going to make any difference at the moment. If I do, let me save first. So the only reason we put this command is to avoid BGP loop. So if I do show IP route BGP, okay, you see there's nothing changed, okay, nothing changed. So so basically that's it for today. So just a bit of a recap. The iBGP configuration between router 1 and router 2 was done in the previous video. In this video, what we did, we made sure we enabled iBGP between router 2 and router 3. And to do that, the first thing we had to make sure that this OSPF running to enable connectivity on the loopback interfaces between those two routers. And once we had connectivity available, we were now able to configure the iBGP between R1 and R2 using the loopback interface for the updates. And then when we did that, we saw that the routes learned the route length on R3, we're having R2 as next hop. So we had to change the next hop on router 2 so that next hop is have the routes that are advertised from R1. In that way, those BGP routes were propagated to router 3, and we're able to have BGP routes on router 3. And after doing all of that, we now enable eBGP again between router 1 and router 2. Okay, and we first of all make sure this interface is up, is pingable between the two routers, and then on router 3, we make sure that we enable the next hop self. Okay, so that to avoid the BGP loops. Of course, enabling this interface and creating eBGP configuration didn't make any difference on the routes, okay, the prefixes that we learned on router 3, but we're going to use it later on for BGP route manipulation. So that's it for this video, and thanks so much for watching, and talk to you in the next video.